All right, this is the Math Models Unit 9, Lesson 5 video. This one might end up being a two-parter, but we'll see how this goes. When it talks about inverse trig functions, it's talking about taking what we were doing in the last lesson and doing it in reverse. In other words, last time we would have an angle, and we would use the angle to find the lengths of the sides. And we would say like the sine of 30 degrees and get this value, and that value was the fraction that we were doing, like the opposite over adjacent or adjacent over hypotenuse or whatever. So now we're taking the answer to that, we're taking the ratio, and we're saying, okay, if the ratio is 0.5, what is the angle? And so that's what it means by inverse. And so I'm going to just jump down here to the bottom and talk through a little bit about how this is going to go. So the first few questions, quite a few, is it says select the degree measures of both acute angles. So this wants us to check two boxes for each of the two angles. So we know, in other words, we know that the legs are 8 and 15. And they want to know, what are the measures of these angles? Because obviously we know this is a 90-degree angle. We don't need to find this. But we're finding these two angles. So it's really simple what you're going to do. You know which ratio deals with the two legs. So I'm just going to jump over to our formula chart. We know that the legs, opposite and adjacent, deal with tangent. So tangent is what we're going to use. But again, we know the answer. We know the answer is 8 and 15. So we don't need to know the answer. We need to go back and find, what is this angle? This is called theta, that symbol. How do I know, if I know this, how do I then find this angle? So the way we're going to do that is on the calculator. There's a button for that. Clear this out. If you're on the main screen of your scientific calculator, click function. And you'll see there's sine, cosine, tangent, and below them, sine -1, cosine -1, tangent -1, which is inverse. So we're going to be doing the inverse of these functions. So since we already determined that we're looking at the tangent, opposite and adjacent, if I go over here and I do the tangent -1, the inverse tangent of 8 and 15, so again, we're going to do 8 divided by 15. So we're finding the tangent inverse of this, and it's going to give us the angle, which it says is 28.07. So that's going to be this answer right here. And then for the other half of this, you actually don't need to do it again, because there's something we know about these three angles. We know this is 90, and we now know this is 28.1. So if I go over here and do 90 minus the answer, this will be the other angle, because these two angles, these two small angles, the acute angles, have to add up to 90. So if the first one is 28.1, the other one has to be 61.9. So that's pretty much how you do that. So in each one of these, you just look at it and you say, okay, I have a leg and a hypotenuse. So it doesn't matter which leg it is. So we're just going to pick either sine or cosine. We'll just use sine as a default. So we are going to say that this is the opposite and this is the hypotenuse. We know that. So that means we're going to be using sine. So I go back to Desmos and I go in and I do sine -1. And then I put in my two numbers with leg on top. 24 divided by 25. Whoa. 24 divided by 25. And go. Okay, so 73.73. Let's see where that is. 73.7. So again, I'm doing the opposite over the hypotenuse. Leg divided by hypotenuse. Hypotenuse always goes in the denominator, always in the bottom of the fraction, no matter what. And then that's the first one, which means that 16.3 has to be the other one, because they add up to 90 degrees. And I could go through that whole thing, but do 90 minus the answer you got for the first one to find the other one. I'll let you do the rest of these. This is going to be like number 1. This is going to be like number 2. All right. Choose the correct answer. Andy is flying a kite in her back pasture. She has let out 100 meters of kite string, and the string makes an angle of 52 degrees. How high is the kite flying? So what you really have to do here is you have to look at the picture and say, okay, we know this is the hypotenuse of that triangle. This is my angle. And this is the thing we don't know. And since it's across from 52, this is the opposite side. The opposite side. And so we know that the sine of 52, is equal to x over 100. So I'm going to try to write this down. It's a little bit of a mess right here, but let me see if I can figure this out. Sine of 52 is equal to x, because that's the opposite, over 100. And so then we just have to solve this equation. So without getting into too much detail, we know we're going to multiply by 100 to get rid of it on this side and multiply it by this over here. So we're going to do 100 times the sine of 52. 100 times the sine of 52. And we get 78.8. Go back and see if we got that. There it is right there. And so that's what I got to do for all of these. You got to figure out which function am I using. And the reason I knew it was sine was because it's opposite for the x and hypotenuse for the 100. Let's jump down to the next one. Similar idea. Andy's attached a remote control micro camera, which is facing straight down and shows the image of her family's pet donkey. How far away is donkey is Andy measured horizontally? So now we're doing adjacent over hypotenuse. Still 52. So we're going to do 100 times the cosine of 52. So the only difference between number 6 and number 5 is that this should be cosine instead of sine. And I'll let you do that one on your own. More of the same. Andy's kite ends up stuck at the top of a tree in the pasture. The tree is 75 meters from where she's standing and 35 feet tall. What angle of elevation does the string make with the ground? So this one's this is basically what you were doing in number 1. You have the two measures and you want to find the angle. And these are the legs. So we're going to go here and we're going to say, okay, tangent of 35 divided by 75. 35 divided by 75. These are the two legs. And we get, I need to be in, I am in degree mode. Make sure I'm in the right mode. There we go, degree mode. There's an issue here. I'm trying to figure out what it is. Let's go back. Tangent of 35 divided by 75. Still getting the same thing. Why is that working? Oh, I'm not using tangent -1. Even I make mistakes. Function tan -1, because again, we're trying to find the angle, not the sides. I was putting in the sides to find the sides, but I want to put the sides to find the angle. There we go. That's more like it. So again, you do tan -1 because you know the sides and you want to find the angle. So that's going to be 25 degrees. I think you can figure this one out. This is the same idea. You want to find the angle, so you do the opposite over the adjacent using the tan -1. Same thing here. Opposite over adjacent. Tan -1. Let's see if we get more of the same. Opposite over adjacent. Tan -1. This is a basic word problem where here's what we got. We have this ladder leaning up against the wall. It touches 12 feet up. It's 5 feet here. You need to use the Pythagorean theorem. I don't know why they suddenly throw this in there, but you need to use the Pythagorean theorem to solve for the missing part. This is going to be the C, or in this case, it's the unknown, but a squared plus b squared equals c squared. Let me mark this out. This is going to be my A. This is going to be my B. And then we're solving for C. C's Pythagorean theorem. I think we did some of those previously. exact same idea. You have the road from Apex to Carrboro, and it's 18. The short leg is from Apex to Bluefield. That's 9. How long is this one? You have a right angle here. You have, this is your C. Whoa. Get a different number here. This is your C. This is your B. This is your A. And solve for A. And then I'm going to let you go ahead and do 13 as well on your own. These are Pythagorean theorems starting from number 11. Pythagorean theorem for all 3 of these. All right. Wasn't too bad.